Today we're going to talk about quadratic functions and characteristics of quadratic functions, meaning the absolute value, yeah, the vertex, the axis of symmetry, the intercepts. So we'll look at finding all of that information for a quadratic function, and we're going to use completing the square to help us get there. So we'll take a peek first at number 5 from the homework. And then we'll see if we can apply that completing the square process to help us graph and find characteristics of quadratic functions. Book homework tonight, I asked that you show some work for 1 through 8. They are matching, so you have a graph, you're matching it to an equation. So show a little bit of work there, meaning the equation has this vertex in it, which is why you chose graph A for number 1. The rest of the problems are going to be similar to those that we covered today. So they will have a little bit of work involved, whether you're completing a square or finding parts of the problem in a different way. Tomorrow is a review day of section 2.1. So while everybody is at home, we'll go through 1 or 2 review problems or kind of solidifying the concepts we talked about today. And tomorrow is also application. So take what we know, see if we can apply it to the outside world. There's a little quiz on Friday, just a heads up. A little quiz on Friday. I'll talk more about tomorrow, but this is just a short little section and we'll take a little quiz. The goal of the quiz is really to be an easy points quiz. Easy way to get points. So that's the goal of Friday's quiz. Your grades were posted yesterday afternoon from the test, chapter 1 test, which you took on Friday. And I have 1 outstanding test that needs to be complete yet. And as soon as that test comes in, I will give you back the test so that you can look to see your errors and go make the test corrections, and then we'll have a retest opportunity for this one. So number 5 on the worksheet. Completing the square. Noah, what do you do first to complete the square?
You move 5 to the right.
Right. If you take that 5 to the other side, no matter what, you have to isolate C. Eliminate C. Get it to the other side. And then Noah, in the same step, what else can we do?
You take 3 out from the left.
Yeah.
3 out.
Let's take a 3 out from the left. So we're going to do this in the same step. The coefficient of x, take the 3 out here too. Squared, we want to take out that 3 value. And I'm going to just do that in the same step, save some more. So eliminate C to the other side, pull out the coefficient, whatever's in front of x squared. The actual process of completing the square after you do that, the whole reason we're completing the square is so that we can have a perfect square trinomial. To get that perfect square value, make sure you're using the b after you factor out that coefficient. And that is a -2. So we're taking -2 divided by 2, squaring it. And when you do that, you get a 1. But on the other side, Maddie, what number do you have on the other side? Oh, 3. A 3. Please be careful with that. Check your homework to see if you did that with the other problems. As I was looking at the homework assignments, I'm noticing that people are not doing that when a coefficient is taken out. So I cannot add a 1 to the other side because it would not be equivalent. Whatever number I have on the left needs to be the same numerical value on the right. And even though, yes, inside you're placing a 1, if I distributed the 3 to everything, really there's a value of 3 on the left, so I need to make sure it's equivalent to the 3 on the right. And then when we factor this, the goal is to get a quantity in parentheses that's squared. This number here, the 1, is my b cut in half. Because squaring it means there are 2 of them, so really I could represent it twice. And a -1 plus a -1 combines to be a -2. On the other side, we get an 8. Any questions with completing the square? Because the completing the square process is done right now. Like that's the process of completing the square. The goal is to get a quantity squared. The next step is to solve for x, which is not part of completing the square, just solving for x. So we'll see if we want to solve for x then, what would you do? Yeah, let's get rid of that 3. Unfortunately, there's an 8 on the other side. If it was a 9, it would work out a lot nicer, but it's an 8. We're going to leave that as 8/3. Don't make it a decimal. Don't make it a mixed number. We're leaving it as a fraction. Lucia, what else would you do?
I would take the square root of both sides.
Yeah, we're trying to get rid of an x squared term or quantity squared. We have to undo it by taking the square root of both sides. And here's where it gets a little tricky. My square root cancels, and we are left with x minus 1. On the other side, I have the square root of 8/3. That really means I have the square root of 8 and the square root of 3. That's the quotient property for radicals. I have a power property also with radicals. I could take something of fractions. I could square the top and square the bottom. Or if the entire fraction is underneath a radical, make sure you notice that entire fraction is underneath, not just the 8, but you're squaring both pieces. So I would take the square root of the top and the square root of the bottom. Now, I know a lot of you, because I had a lot of questions on the homework form, were wondering how I got my answer. And I think part of it is because most people, as I was looking at the homework, didn't take the square root of 3, and they just took the square root of 8. And you made it 2 square root of 2 over 3. Well, you have to take the square root of both parts of the fraction because both parts of the fraction are underneath the radical. Fractions are really picky. Mr. Kane would tell you that I'm really picky too, but he lies. I'm not picky, not at all. But a fraction's denominator is really picky. It's only allowed to be a whole number, which means a number from 1 to infinity. It cannot be a negative. It cannot be 0. It cannot be a square root. And when we get to imaginary numbers, it cannot be an imaginary number. So this has a square root. How do you get a square root out of the denominator of a fraction? How did you do that? How would you do that? Lucia, do you remember?
You could multiply by the square root of 3.
Yeah, so if you multiply it by itself, a square root of 3 times its same square root of 3 is the square root of 9. The square root of 9 just becomes the number 3, and I no longer have a square root in the denominator. Does anybody remember what that process is called when you're trying to get a radical or a square root out of the denominator? It begins with an R. It's a pretty big word. It's called rationalizing the denominator. So we're trying to make that denominator not have a radical in it. That process is called rationalizing the denominator. So now our denominator is just the number 3, because when you multiply a square root by itself, you have the square root of 9, which becomes 3, or you could say the square roots cancel each other out. It's kind of the same property. This is just now the number 3. But on the top, when you multiply those together, Tyler, the square root of 8 and the square root of 3, they become
Square root of 24.
square root of 24. So you still have to multiply the top together as well. You can't just leave them separate. Is there anything you could do with the square root of 24, Tyler? Can we break that down at all?
Yeah.
How can we break it down?
Split it into 6 and 4.
Right, square root of 6 and 4. So we initially had the square root of 8 times 3. Well, we multiplied those together to get 24. But now I'm telling you to break that down again, because we need to break it down so that it's a perfect square. So 4 goes into 24. 4 is a perfect square and becomes the value of 2. The square root of 6 is not a perfect square. It cannot be broken down, so it just stays as the square root of 6. And then that 3 is now our whole number in the denominator. If I solve this by taking the 1 to the other side, I have the 1 a plus or a minus because we solved something that was x squared. And then 2 root 6 over 3. So if you were checking your answers and wondering how the heck did Mrs. Kane get a square root of 6 on the top, because I think a lot of people had a square root of 2 on the top, it's because you have to rationalize the denominator. That's a concept that was talked about last year and in geometry. And again, like you use it in math, you learn it in math, you'll see it again. It'll pop up again and again. Any questions with number 5? That was I think the most involved question out of all of them. It's the only one that required you to rationalize the denominator. Any questions? So we are going to use this process of completing the square to help us graph quadratic functions and find out characteristics of quadratic functions, meaning the vertex, the axis of symmetry, and the intercepts. When you solve for x, this is really an intercept of the graph. So we're going to be using this process to find the x-intercepts. But when you're solving for x, you're finding the x-intercepts. We just sometimes don't associate that with the graph because you're just finding x. But when you're finding x graphically, you're finding those x-intercepts. So we'll do that part too today so we can get those x-intercepts as well. Any questions? So if you want to take out your notes, if you have the notes out and it's just one big slide, it's the next page in Notability. Or if you have separate notes somewhere, we're looking at section 2.1, talking about quadratic functions, which is a type of a polynomial. So polynomial would be the big name for the function. It's a big bubble. So think of like quadrilaterals is the big name of a 4-sided figure in geometry. And then you have your square and your kite and your rhombus and your rectangle. Well, a polynomial is the big name for a lot of functions that have positive exponent powers. Underneath, there's a little table of value for you to kind of just understand how a polynomial builds on itself. So the first function is called the constant function, which means it's just horizontal. It's not rising or falling, it's constant. That function is of the form f of x equals a, or I could also say it's of the form y equals maybe 5, pick your favorite number. But it's just our horizontal line. This is still considered a polynomial function because my power is 0. So x to the 0 power, well, there's still an x there, it just has a 0 power. That coefficient in front is what's creating our constant line at whatever place it happens to be. The next function builds on the previous. So our next line function, linear function, has a power of 1. So if I add an x to the equation with the power of 1, now it creates something that increases or decreases. So my linear function, ax plus b, keeping the a the same, so you can see that constant and how it changes once it has a variable next to it. So that is our straight line. And then raising that power to a 2, again, creates a new function, keeping the a in the same place. The b now goes along with the x, and I have that c value. And I could continue this pattern. So we could say ax cubed, and then I'm just adding extra variables and extra coefficients. That would then be my cubic function. But one function is really building off of the other. By raising the power of x, it changes the curve of the graph. So an x cubed graph has an extra curve. An x to the 4th graph is actually a w. So the powers start to change the shape of the graph and the curves in the graph. Specifically, though, we're going to look at the quadratic function in this section and give you a little review. So there are 2 little graphs here. The first one on the left says a is greater than 0. A is the number in front of x squared. That's our coefficient. That tells us how steep the graph is, how wide the graph is. It also tells us if the graph is going to go up or the graph is going to go down. So if I had an equation, I just chose 3x squared plus 1. that tells me my graph is going to go up 1. That 3 would be the stretch vertically of the graph. But the key thing is, if that A value is bigger than 0, the vertex, which is the little dimple, if this is my happy parabola, a little dimple at chin, that's our vertex. And that vertex is a minimum, and this graph opens up. So the number in front tells us 2 things. It tells us the direction of the graph, and that the vertex of the graph is either a minimum or a maximum. When it's positive, it's a minimum, because it's the lowest point. Everything else is going above it. So if I change that equation to be a negative 3x squared plus 1, my graph now flips down. The negative reflects it over the x-axis. And makes a frown. So my sad graph, frowning, still has a vertex. There's a dimple on its chin. But that vertex is now a maximum because it's the highest point of our graph. That happens when the graph opens down. So if it opens down, it creates a frown, but the highest point is the vertex. So again, just by looking at the A value, I can say it goes up or it goes down. I can say the vertex is a minimum if it goes up, it's the lowest point, or a maximum if it goes down. And we're going to kind of look at that. That's going to be a question that you're going to be answering. What direction does the parabola open? Does it open up or does it open down? Does it make a max or does it make a min? Questions? So there are 2 ways to write a quadratic function. The form right here is called general form, ax squared plus bx plus c. That's probably the way that you'd usually see a quadratic function written. When you're factoring, when you're using the quadratic formula, it's an ax squared plus bx plus c form. So that's called general form. So I'm going to write that again, right here. Standard form is underneath. And standard form is the form where I have the h and the k back from chapter P. All those functions we graph, the quick functions, have the h and k in it. Standard form is also known as graphing form. I can quickly graph a function by using the numbers in standard form. We're going to first talk about the axis of symmetry, though, what it means if my graph was in this general form or my equation was in a general form. So we just said from before that the vertex is the highest or the lowest point. Tyler, what's the axis of symmetry?
HPC.
Well, not even in the equation, but what does it mean if it's an axis of symmetry?
Or the equations the same on both sides.
Yeah, so the same on both sides. So I'll say splits graph in half. Something has symmetry, it has a mirror image, the same image on each side. It's in the middle of the graph. That'll be another way. But it's a line. So it's a line. That's what the axis part means. That splits the graph in half. There are 2 ways to find the axis of symmetry, and it depends on the form you're given. If I'm given general form, there was an equation last year that you use to calculate the axis of symmetry, or more like a formula that you use to find the axis of symmetry. And it used the letters in the general form. Does anybody remember the formula or the equation for the axis of symmetry? It was a fraction. Has to be x equals because it's a vertical line splitting our graph in half. So the axis of symmetry we drew as that like dashed line that went through the graph. Anybody at home remember the equation or the formula for the axis of symmetry?
Is it B divided by C?
No, but there is a B on top. We can play hangman. There's a negative sign on top as well.
Is it over A?
Say it again.
Is it over A?
Oh, you're so close. There's something with that A. Close. Hmm.
2A.
Yeah, there's a 2A with it. So negative B divided by 2A. Yeah. So 2A on the bottom. That's the axis of symmetry. That's the line that cuts the graph in half. I use this equation when I have general form. 65 from your homework tonight. You're going to use this equation because it's going to be in general form, and you're not going to be able to complete the square because there's fractions in it. And completing the square with fractions is pretty challenging. So you're going to want to use general form for 65 tonight. However, if we have standard form, that's the other form, I can find the vertex and the axis of symmetry by using the numbers in the equation. So from the previous two chapters, does anybody remember what the vertex would be if I have this standard form?
Okay.
Yeah, H and K. And remember the minus sign is part of the equation. So X minus, that's the standard form. The H represents how far I shift to the right. The K represents how far we go up. Well, that tells me the location of my vertex. So here's the vertex. That's H and K. The axis of symmetry, if I have this form, I don't need to use negative B divided by 2A. It's just H. Because the axis of symmetry cuts right through the vertex. They meet at the same X value. The middle of the graph is my axis of symmetry, but it's also the location of the point for the vertex. So if I have standard form, I could use negative B divided by 2A, especially if your original equation starts out looking messy with fractions. If general form, I'm sorry. If I have standard form, which is what we're going to try and create, I can just pull the numbers out of the equation. So if you look at the first example, we have a quadratic function, and it says to write the function in standard form. So we're going to try and take this function and write it so that it is in the form x minus h squared plus k. What method do you think we would use to get it to look like standard form? What process? What did you do yesterday for your homework? Completing the square. So we're going to use completing the square. Now I'm going to change this just a little bit. I'm going to take the f of x and make it equal to 0 so that it looks more like an equation. And we're going to eliminate c to take it to the other side. So we're going to see if we can complete the square to get this in standard form. So my c value, I'm taking to the other side. I like having that c on the right side. That's just a me thing. It doesn't have to be a you thing. But I essentially just move the equal side to be on this side of the equation instead of the other side. What would you do to complete the square? So Maya, what would the first thing be that we'd have to do to complete the square? Yeah, take out the 4. So let's factor out a 4. And then Maya, what else would you do?
Then we have to find the C.
Yeah, we have to find the new c. Yeah, we gotta get that new number. And to do that, we take b divided by 2 and square it. Well, b is -1. You're using the new b, which is -1, dividing that by 2 and squaring it. Uh-oh, got a fraction. Maddie, what is negative 1/2 squared?
Would it be negative, or 0.25?
0.25, give it to me as a fraction.
1/4.
There you go, 1/4. This isn't so bad. Yeah, I know there's a fraction there, but remember the number out front, that 4, has to multiply the 1/4. So Tyler, that means on the other side, you're adding a 1, which is kind of nice. I'm adding 1. At least it's not another 1/4 or 1/2. So factor equals negative 20. Remember, you're taking b and dividing it by 2. That's what goes in my factored form, which is negative 1/2. Because I have that squared, which means there are 2 of them. A negative 1/2 and a negative 1/2 add to be a negative 1. That's the process of completing the square. If I want to get it into standard form, I don't want to solve any further. I just want to take this back so that it says f of x equals a times x minus h squared. And then I need the k to be on that same side. Well, that's the minus 20. So if I just add that 20 to the other side, now I have standard form. So completing the square takes a parabola from general to standard form. Essentially, we're rewriting the form of the parabola. Questions? The next part I should be able to answer fairly quickly now because I have standard form. It asks for the axis of symmetry, which I just label as AOS because I don't like writing out all those words. And it asks for the vertex. And you should be able to pull the numbers out of the equation, and that's your axis of symmetry and your vertex. So Emma, the axis of symmetry is 1/2. And the vertex is
1/2.
3. So completing the square makes those 2 parts really easy to find. The last part says find the intercepts. What are the intercepts? Lucia, what are the intercepts?
Where the line crosses the x or y.
Yeah, where the line crosses the x or the y axis. Which means the y is 0 or the x is 0. Now, we're going to do a little cheating here. Not really cheating. But if I want to find x-intercepts, that means you're solving for x, which were the 10 problems you did on the worksheet. I underlined this equation up here. I'll box it. If I continue to use that equation and solve for x, I've already done the completing the square part. I can just use it and find x, which is the same thing as the x-intercept. So I'm going to take that equation that I already worked for completing the square. I'm going to use it to continue to find x or the x-intercepts. Because I did set it equal to 0 to complete the square, so I might as well keep using that and solving to find my x values. So Tyler, to solve this, you would divide by 4. And then what would you do, Tyler? Square root. What happens when you take the square root of the right side? What happens with that? What's the square root of -5? What's the rule with the square root of a negative number? Bridget?
It's imaginary.
It's imaginary. So Bridget, if I cannot take the square root of -5 because that means it's imaginary, what do you think that means about the x-intercepts?
They're not real.
They're not real. So they're not real. There is no x-intercepts. They're imaginary. So if it's equal to a negative number, and I'm dividing by a positive number, there aren't going to be any x-intercepts. We're going to find the y-intercept, and I want you to go back and think about finding a y-intercept. There's an easy way that involves no work. There's a harder way that involves some work. To find a y-intercept, it's when the x value is equal to 0. What equation could you use to find the y-intercept and do no work whatsoever? This one up here? This one right here? We'd have to do a little bit of work because I'd have to plug this in.
No, isn't it that one?
This one right here?
Yeah.
Yeah, okay. I'd still have to do a little bit of work because I'd have to plug a 0 in, take 1/2 and square it, multiply it by 4, which we could do. I mean, that's not a lot of work. But if I use this original equation right here, where we started, what happens if you plug a 0 in for x, Bridget? I plug a 0 here and a 0 here.
They cancel out.
They cancel out. What's your intercept going to be then?
21.
21. The y-intercept is always that c value, A, B, C. Could you do it the other way? Yes. As long as you plug a 0 in for x somewhere, you're finding a y-intercept. Both of them are pretty easy. But that y-intercept using the original equation that they give you, it's that last number, always, every single time. Questions? All right, so I want you to think about one thing. If you were graphing this, we have our vertex at 1/2 and 20. So we'll say this is 1/2. This is not drawn to scale. Up there is 20. Why don't we have a y-intercept or an x-intercept? So why isn't there an x-intercept? Based off of the vertex, think about the graph. What's going to happen to the graph? No idea, no?
It's not crossing the x-axis.
It's not crossing the x-axis because its vertex is starting way up there. And that vertex is actually its lowest point. Whoops, I didn't even make it into the lowest point. There's no x-intercepts because it has to cross the x-axis. That's what Lucia said x-intercepts and y-intercepts were. If it doesn't cross, it doesn't have an x-intercept. So graphically, to support those x-intercepts, think about what it means graphically. Does anybody have questions? My goal for you this year is not to just like, Mrs. Kane told me it's the way it is because it's what she said, but to get you to think the relationship between a number and a graph and how those two are built together. Not just to be like, oh, it's because what she said it is, it is. She said that's the way it was. So being able to pull things together and not just be like, I'm going to trust Mrs. Kane all the time. I mean, maybe you could. That would be nice, but I promise I won't lie to you. But still, trying to think about what it means. So I'd like you to look at the next problem, and we're going to do the same thing so you feel a little more comfortable getting a second problem done. For some reason, I missed the N both times here when I was typing. Given the function f of x equals negative x squared minus 4x plus 1. Again, we're finding the vertex, the axis of symmetry, the intercepts, and then it says the direction of the parabola. So think about completing the square. I'm taking this and setting it equal to 0, but I like to see the other side equal to 0. It's just me. I like to have my number on the right and the axis on the left. That's just a me thing. Is there a coefficient that you have to factor out for this problem? Emma, what do you think?
Yeah, you have to take out a -1.
Yeah, you still need to take out a -1 because there's still something with x squared. It's negative x squared. So we have to factor that out. Make sure that you factor it out of the negative 4x as well. Question from third period. Can you take the x squared to the other side and make it positive? You actually cannot do that because that changes then the direction of my graph. So this graph is negative because it should go down. If I move the x squared to the other side to make it positive, now my graph is going up. So I cannot move x squared to change the fact that it's positive versus negative. I need to keep the original shape going down. Maddie, what number do you have to complete the square?
You have 4.
But on the other side, what number are you going to add?
-4.
Nice job, not getting tricked there. So you're adding a -4, even though I still put a +4. Come on, Mrs. K. Here we go. So that gives us a -5. So again, we're going to use the rest of that equation when we find the intercepts. But my standard form is negative x plus 2 squared. Adding the 5 places it in standard form. So standard form, everything should be back on the same side. So x-intercepts, vertex, axis of symmetry, y-intercept should be no work. Just the x-intercepts. That's the rest of the work that we have to do for this problem. So Tyler, our vertex is,
-2,5.
I can't see it, I scrolled down too far. There we go. And then the axis of symmetry.
-2.
Nice job. Remember that minus is x minus standard form. That +2 is really minus a -2. Without doing much work, we can get the y-intercept. That c value in the original problem is just a 1. Or you could say, I like doing a little bit of work. You could plug a 0 in here. 0 plus 2 squared is 4. There's a negative sign in front, so -4 plus 5 is still 1. To get the x-intercepts, I'm going to take the equation that I have up here that I completed the square with, and I'm now going to solve. So I'm using the -1. X plus 2 squared equals -5. This time, it actually works out because there's a -1 in front that I have to divide by first. And now I have a -1 or -5 divided by a -1, which makes it a +5. So the previous one, I had a -5. This problem here, we have a +5. And you can take the square root of a positive number. So Noah, my x-intercept would be at,
-2 plus or minus the square root of 5.
and to make it an intercept, I'm going to cheat, put a 0 around it, and make it a point, an ordered pair. Does the graph go up or down? What do you think, Noah?
Down.
Down. And that's because there's a negative in front of my x squared, or there's a negative in front of the parentheses. Any questions on that problem? So I believe you have like 3 of them tonight that are going to look like this. You'll just complete the square and kind of get used to finding all the information. There is one last problem that I'm just going to talk about. You have 2 problems from your homework like this, and I want you to see how to set it up. Example 3 wants you to find the function that has a vertex, which is really h and k, at -2, 2. And a point, well, any other point on the graph represents x, y. So I have this parabola, I just don't know what the equation is. Our goal is to find the function that would represent this parabola. What do you think you could do with these values to find the function? It's Ms. Carp's favorite word that she gets yelled at all the time. 2 words. Ms. Carp, why do you get yelled at? What words do you get yelled at for? Plug in. Oh, she's like, I'm so confused, Mrs. King. She's not allowed to say plug in when her teacher from Penn State observes her. It has to be substitute. So we're using correct math words. Are you okay if I use plug in? I don't know. So plug these numbers in and then you'll be solving for the
Please pardon me
the
interruption.
value.
All NHA swim athletes, your practice has been canceled for today. Please go home after school. That's the NHA swim program. Your practice has been canceled for today. Go home after school. Thank you.
So tomorrow, we will kind of wrap this up. We'll work through another problem together, probably answer a couple homework problems, not moving on tomorrow. Have a fantastic day. If you drive or get a ride in a vehicle, not a bus, see you later. Have a good one. Thanks, you too. Everybody at home, have a great day.